We talked about it last week. We talked about it yesterday. What is a polynomial, Seth?
Numbers that are like split up by like addition and subtraction.
Okay, so there are terms that are separated by addition and subtraction signs. A monomial yesterday was a singular term. Today we're going to look at binomials and trinomials. What do you think a binomial is? 2 terms. Trinomial, 3 terms. And those are all in general classified as polynomials. Okay? There are 2 different methods we're going to look at. We're going to look at the FOIL method and the box method. You use whatever one you want. When we get into multiplying like a trinomial times a trinomial, the box method's nice because it organizes your work a little bit, but the FOIL method works. If you like the box all the way through, then you do the box. If you like FOIL, you're going to FOIL. Okay? The very first problem, I'm going to show you using both methods. And then we can decide as a class which one we like the best. Cool? Okay. So let's multiply out x plus 5 times x plus 2. I know I'm prepared this year so far. Okay, so FOIL method. FOIL stands for first, outside, inside, last. First, outside, inside, last. Okay? Basically, you're distributing twice. So, if we're multiplying, if we use the first, you multiply the first 2 terms in each binomial. So, x times x is x squared. Okay? O stands for outside. So I multiply the outside terms, which would be the x and that 2. What is x times 2? 2x. I stands for inside. So we multiply the inside terms. 5 times x, 5x. L stands for last, so you multiply the last terms. 5 times 2, 10. We sure can't leave our answer like that. Is there anything I can combine? The 2x and the 5x, right? So I would have x squared plus 7x plus 10. As my final answer. Okay, so again, what you're doing is you're distributing twice. So I multiplied this x by both of these terms, and then I multiplied this 5 by both of those terms. Now let me show you the exact same problem with the box method, and I want you to write down the box method so you have both options to look at, and then we can decide which one we like. Okay, because it's a binomial times a binomial, I'm going to create a box that has 2 columns and 2 rows. Along the top of the box, I'm going to put my first term, x, and then technically a positive 5. You don't have to write the plus, but you can. You do need to write negatives, though. Down the side of the box, I'm going to do my x plus 2. Again, this is going to be helpful when we look at a trinomial versus a trinomial. To get in the box, we multiply. So this box here are these 2 pieces. X times x is x squared. What do you think goes in this box? X times 5, the 2 pieces that create that box. So 5x. What goes in this box? 2x. And in this box, 10. Okay, I get the exact same terms I got when I did the FOIL method. Now you'll notice that your diagonals are your like terms. To get out of the box, you add or you combine like terms. There's nothing to combine with x squared, so I'm going to rewrite it. 2x plus 5x is 7x, and then that 10 attaches. So to get in the box, we multiply. To get out of the box, we combine like terms. Okay? So let's look at question 2, and we won't do both methods every time. We'll pick which one we like the best. And if you don't like the one the class chooses, then you use the other one, and as long as your answer matches ours, then you're good, right? So 2x plus 4 times x plus 3. Would you like to do this one together, or do you want to try it? Try it? Okay, so choose either the box or the FOIL method and try it, and then once you have an answer, check with your group and see if they have the same answer you do. So FOIL says, I'm going to multiply my first terms, so 2x squared. My outside terms, so 2x times 3 is 6x. My inside terms, which is 4x, and my last terms, which give me 12. Whoops, I forgot an x. When you combine like terms, you should have 2x squared plus 10x plus 12 as your final answer. Do we get that? Awesome. Did you get that even if you use the box? Does anyone need to see the box with this problem? No? Okay. So let's try now with a binomial times a trinomial. So the FOIL method still works, but it's not technically FOIL anymore because we don't have just an inside and outside term. But if you're going to use that method, you're going to take x and you're going to distribute it to all 3 terms. Then you're going to take your 2 and distribute it to all 3 terms. If you use box, you'll have a 2 by 3 for your box. So let me do this one with the box method. If you want to go ahead and do the FOIL method, you can. But if I create a box, it's going to be 2 rows by 3 columns because I have a 2 by 3. So my 2 rows is x plus 2, and across the top is x squared minus 5x and that positive 4. Yeah.
Does it matter which way you do the box?
No, so if you did the box vertical and you have a 2 on top and the 3 on the side, that's fine too. I just like to save space if I can. Okay, so if I multiply in x times x squared, x to the third, x times negative 5x, negative 5x squared, someone other than Carlos, x times 4, 4x, x squared times 2, 2x squared, 2 times negative 5x, negative 10x, and 2 times 4 is a positive 8. Now again, when you have a box, your like terms are diagonal from each other. So I have a 2x squared and a minus 5x squared, and then I also have a negative 10 and a 4x. Okay, so let's rewrite what we can and then combine. So I'm going to pull out this x to the third because there's nothing to combine it with. What is 2x squared minus 5x squared? A minus 3x squared. Negative 10 plus 4, negative 6x, and then I have the 8 on the outside. So again, the FOIL method works. You would just multiply x times each of these, which is what I did, right? I multiplied x times each of those terms, and then I multiplied 2 times each of those terms. Whatever works for you. Micah?
I tried to use the FOIL method, and it seems harder with the
The FOIL method does?
Yeah.
So the thing with the FOIL method, with a binomial and a trinomial is you have to make sure you hit every single term, which is why I like the box for organization. So if you want to do FOIL for binomials and then use a box for everything else, that's fine. You can switch up the method however you want. But if you were going to multiply it out, it would be x times each of these terms, and then it would be 2 times each of those terms.
Well, why does it change when? Why does it change when it goes from binomial to trinomial?
It doesn't. So you're literally here doing x times both of those terms, because it was x squared and then 2x, and then here is 5 times both of those terms. So it doesn't change, there's just more to multiply with a trinomial. Okay, so why don't you guys try this next one on your own, and then we're going to do one more after this and call it a day. Actually, I'm going to give you both right now. So one more binomial times a trinomial. And then I'm also going to give you a trinomial times a trinomial. No, 3 terms times 3 terms. Okay, so choose your method. And then once you're done, check with your group. Okay, let's see how you did. I'm going to do the box again. If you foiled, that's fine. So when I multiply inside my box, I get a negative 6x to the third of 15x squared and a minus 18x. I get a positive 8x squared, a minus 20x, and a positive 24. So negative 6x to the third, 8 plus 15 is 23x squared. Negative 20 minus 18 is a negative 38x, and then I have that plus 24 at the end. Do we get that? Yes? No? Maybe? Yeah? Okay. 3 by 3s. Again, if you're going to do a 3 by 3 using the FOIL method, you multiply the first term by everything, then the second term by everything, the last term by everything, and combine like terms. Or you can organize it in the box. It's the same thing, just a different way to organize it. So I'm going to do 2x squared, 3x, and 1, and then x squared minus 5x and 7. When I multiply in, I get 2x to the fourth, negative 10x to the third, 14x squared. 3x to the third, negative 15x squared, 21x, and then x squared, negative 5x, and 7. My x to the fourth is by itself, so 2x to the fourth. Again, the diagonal are my like terms, so 3 minus 10 is a negative 7x to the third. Then I have 1 minus 15 plus 14. What's 1 minus 15? Negative 14. Negative 14 plus 14? 0. Those are gone. And then you have negative 5 plus 21 is a positive 16x, and then the 7 at the end. Did we get that answer? Yeah? Okay. Any questions, comments, concerns on multiplying? So multiplying from yesterday and multiplying from today, along with adding and subtracting, will be on your quiz on Friday. We're good?